We continue miscellaneous exercise on chapter 9. The question we have completed question number 4. Now we discuss question number 5. Find the sum of integers from 1 and 100. Find the sum of integers. Find the sum of integers from 1 and 100. Sum of integers from 1 and 100. From 1 to 100. From 1 to 100. From 1 to 100 that are divisible by 2 or 5. That are divisible by 2 or 5. Find the sum of integers from 1 to 100 which are divisible by 2 or 5. So first we find the sum of integers between 1 from 1 and 100. Sum of integers from 1 and 100. From 1 to 100 that are divisible by 2. Sum of integers. Sum of integers from 1 to 100 divisible by 2. First we find the sum of integers from 1 to 100 that are divisible by 2. So the first integer is 2, 4, 6, 8, 10 and the last integer is 100 because 100 is divisible by 2. 100 is divisible by 2. So the first term a equals to 2. The common difference b is also 2 and the last term an equals to 100. We find the total number of terms. We calculate the total number of terms between from 1 to 100 that are divisible by 2. So the formula for an equals to a plus n minus 1 into d. And the last term an is 100, the first term is 2. Total number of terms we have to calculate, common difference is also 2. So 100 minus 2, 98 equals to 2 into n minus 1. And the value of n minus 1 is 98 by 2, that is 49. And n equals to 49 plus 1, that is 50. So the total number of terms from 1 to 100 that are divisible by 2 is 50. Now we find the sum. So Sn equals to n by 2, a plus an, first term plus last term. The total number of term is 50 by 2. The first term is 2 and the last term is 100. So it gives 25 into 100 plus 2, 102. And 102 multiplied by 25. 102 multiplied by 25. So we get 10, 1, 5, 4, 0 and 2. 0552. 2550. 2550. This is the sum of integers from 1 to 100 that are divisible by 2. Now we find the sum of integers. Sum of integers from 1 to 100. Sum of integers from 1 to 100 divisible by 5. Divisible by 5. So the first number which are divisible by 5 from 1 to 100 is 5, then 10, 15, 20, and the last number is again 100, because 100 is divisible by 5 also. So here the first term A is 5, the common difference B is 10, and the last term AN is 100. Again we calculate the value of N. So AN equals to A plus N minus 1 into D. And the value of N is 100. The first term is 5, N minus 1, and common difference is 5. 10 minus 5, 5. So 100 minus 5, that is 95, equals to 5 times of N minus 1. And we get the value of N minus 1 equals to 19, and N equals to 20. Then we calculate their sum. So Sn equals to N by 2 and A plus An. 20 by 2, the first term is 5, the last term is 100. Then we get 10 into 100 plus 5, 105, and that is 1050. So the sum of numbers from 1 to 100 that are divisible by 5 is 1050. Now we calculate the sum of the numbers, sum of integers, sum of integers from 1 to 100 divisible by 2 and 5 both. Divisible by 2 and 5 both. Those numbers which are divisible by 2 as well as divisible by 5. So the first number which is divisible by 2 as well as 5 is 10, 20, 30, and the last number which are divisible by 2 and 5 is 100. Now again we find the number of terms. How many such numbers are? The value of A is 10, common difference is 10, and the last term An is 100. So An equals to A plus N minus 1 into D. 100 equals to 10 plus N minus 1 into 10. This becomes 90 equals to 10 into N minus 1. And the value of N minus 1 equals to 9. And N equals to 9 plus 1. So there are 10 such numbers. There are 10 such numbers from 1 and 100 that are divisible by both 2 and 5. Then again we calculate the sum of those numbers. So N by 2, A plus An. The value of N is 10, so 10 by 2, The first term is 10, the last term is 100. So 10, 2 5 are 10. We get 5 into 110. That is 550. Sn equals to 550. So we add the sum of numbers divisible by 2 and the numbers divisible by 5, and then we subtract the sum of the number divisible by 2 and 5 both. So the required sum equals to 2550 plus 1050 and subtracted 550. So 2550 plus 1050, 0, 10, 6, 3600 and 3600 minus 550. We get 3050. 3050. 2550 plus 1050, that is 3600 minus 550, which is 3050. So this is the required sum. So first we calculate the sum of the numbers that are divisible by 2 from 1 to 100. Then the sum of the numbers that are divisible by 5 from 1 to 100. Then we find the sum of integers that are divisible by both 2 and 5. Then we add first two sums and subtract the sum of numbers that are divisible by both 2 and 5. कैसे नहीं कहा? हाँ? Then let us see question number 6. Question number 6. Find the sum of all two-digit numbers which when divided by 4 yield 1 as remainder. We have to find the sum of all two-digit number which when divided by 4 gives a remainder 1. So the first two-digit number which when divided by 4 gives a remainder 1. The first number is 13. Two-digit number when divided by 4 gives a remainder 13. So when 13 is divided by 4, the remainder will be 1. Second two-digit number when divided by 4 gives a remainder 1. What would be? That would be 17. 4 4 ja 16. The remainder comes to be 1. Then the next number will be 21. Then 25. And the last two digit number, when divided by 4, gives the remainder 1. That is 97. When 97 is divided by 4, it gives a remainder 1. So the first two digits number is 13. The value of A is 13. Common difference D is 4. And the last term AN is 97. First we calculate the total number of terms between total number of two digit numbers, total two digit numbers that are when divisible by 4 gives a remainder 1. So the formula for AN equals to A plus N minus 1 into D. And the N is 97. First term is 13. And number of terms we have to calculate, the value of D is 4. So 97 minus 13 equals to 4 into N minus 1. 84 equals to 4 times of N minus 1. And N minus 1 equals to 21. 21 4 ja 84. And the value of N equals to 22. So we get the value of N equals to 22. Now we have to find their sum. So Sn equals to N by 2 A plus An. N is the total number of terms, that is 22. First term is 13 and the last term is 97. So it goes by 11. 11 into 97 plus 13. 110. And the result is 1210. 1210. The next question number 7. Question number 7. If f is a function satisfied, f is a function satisfied fx plus y equals to f of x into f of y. Fx plus y is equals to fx into fy. For all xy belongs to N. For all xy belongs to natural number N. We have given the condition that f of x plus y equals to fx into fy for all xy belongs to N, such that f1 equals to 3. Such that the value of f of 1 equals to 3. F of 1 equals to 3 and sigma x equals to 1 to n and sigma x equals to 1 to n. F of x equals to 120. F of x is equals to 120. Then find the value of n. Find the value of n. So the condition which we have given, f of x plus y equals to f of x into f of y, and f of 1 is given 3. Then we calculate f of 2. f of 2. f of 2 can be written as f of 1 plus 1. This 2 can be written as 1 plus 1. Means at the place of x there is 1, and also at the place of y there is 1. So if fx plus y is written as fx into fy, then f1 plus 1 is also written as f of 1 into f of 1. And the value of f of 1 is 3, and also f of 1 is 3. So 3 into 3 equals to 9. So we get the value of f of 2 equals to 9. And the value of f of 1 was already given 3. Then we calculate the value of f of 3. So f of 3 can be written as f of 1 plus 2, and f of 1 plus 2 is given by f of 1 into f of 2. The value of f of 1 is 3. The value of f of 2 we have calculated 9. So we get 3 into 9 equals to 27. So the value of f of 3 is 27. In the same way, we can calculate the value of f of 4. So f of 4 can be written as f of 1 plus 3. 4 can be written as 1 plus 3, and f1 plus 3 is written as f of 1 into f of 3. And the value of f of 1 is 3, and the value of f of 3 is 27. So f of 4 we get 81. Then we have to find the summation fx. This summation fx can be written as f of 1 plus f of 2 plus f of 3 plus dash dash f of n. Put the value of f1, the value of f1 is 3, the value of f2 is 9, f3 is 27, f4 is 81, plus dash dash up to n terms. And their sum is already given. Their sum is 122. This is 122. This sequence is a GP, and sum to n terms of GP is given 120. The first term A is 3. Common ratio is also 3. So we use the formula for finding the sum. A into r raised to the power n minus 1 upon r minus 1 equals to 120. The value of A is 3. The value of r is also 3. N we have to find. Upon r minus 1 means 3 minus 1 equals to 120. So 3 upon 2 and 3 raised to the power n minus 1 equals to 120. Then by cross multiply, 3 raised to the power n minus 1 is written as 120 into 2 upon 3. It goes by 40. So 3 raised to the power n minus 1 equals to 80. 3 raised to the power n equals to 81. And 81 can be written as 3 raised to the power 4. So 3 and 3 gets cancelled. And we find the value of n equals to 4. The value of n which we get 4. And we have to calculate the value of n. So the result is 4.